Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia.
Testing dengar ke tak?
Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai. Hai. Okay, good evening teachers, parents and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our section by reciting a prayer for Muslims. The non-Muslims may pray according to your own religion. Let me introduce myself. I'm Teacher Kong from College Matriculasi Perak, the moderator of the day. Here at Pusat Tuisyen Academy YouTuber, we provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Mawar from Ministry of Education. We are now live on Cikgu Mawar channel. Please support her channel by clicking subscribe now. The topic of today's lesson is liquid and solid. And together with us, we also have Cikgu Shanut from College Matriculasi Pulau Pinang, who is control host, in charge ensure the smoothness of our lesson on technical support. And Teacher Bibi Lau from Pusat Tingkatan 6 SMK Pulau as observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson, stop chatting and use the chat section wisely. Number 2, regarding certificate link, the link will be given at the end of our section. Please use the email pdidik.edu.my, email moedl.edu.my, email myguru.edu.my, or email jawi.edu.my. When you fill in your particulars, and make sure to listen to passcode given by the presenter or moderator from the time. And fill in the form within the time limit, which is 30 minutes. Now, I would like to announce the first 3 passcodes, which are A11, A11, A11. So, without further ado, let's welcome Cikgu Mawar.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. Okay, terima kasih kepada Teacher Kong sebagai moderator and Cikgu Shahnan sebagai control host dan juga Teacher Bibi Lau sebagai pemerhati. Okay, now, before I continue my lesson, let's introduce the team Kimia Prayu, monitored by Teacher Cikgu Shahnon. We have Mathematics group, monitored by Teacher Im. Biology group, monitored by Cikgu Faiza. Okay, we have Physics team, monitored by Cikgu Rusmaya, and also Perakaunan and Ekonomi Prayu, monitored by Madam Fizi. Okay, so today's topic, I will continue from the Teacher Tang's from the previous lesson. So for today, I will explain, we show you the topic of liquid and solid. So this is the group of solid and this is the group of liquid, and this is the group of solid. Okay, so we first go to the syllabus of matriculation and STPM. Okay, we assume looks alike, but for the STPM syllabus, they added some subtopic which is describing the allotropes of carbon. So I will explain all. All right. Okay, I start my lesson today, by explain about the liquid. Okay, now we go to the properties of liquid. So we have 6 properties of liquid, which is we have shape, Okay, we have volume, we have surface tension, we have viscosity, and also compressibility. Okay, and then we go first to the first and second properties. Okay, now this is the shapes and volume of liquid, and that we know that the liquid does not have a definite shapes and size. Okay, meanwhile, the liquid have the fixed volume, but the shapes follows the container which holds the liquid. Okay, let me do the simple experiment here. Okay, now we have 100 ml of water. Now we put the water into the conical flask. Okay, what we see that the water is remain 100 ml of volume. Okay, now we pour the 100 ml of water again into the beaker with different shapes. Okay, so we can see that the volume remain as 100 ml. And we pour again into the measuring cylinder. Okay, what we can see that the volume is remain 100 ml volume. Okay, so we can assume that the shapes of volume does not have a definite shape and size, but it do have the fixed volume, and the shape is follow the container which hold the liquid. Okay, next, the third properties of liquid, it is the surface tension. So this is the example of surface tension. Okay, which is we can see the inside that what on the top of the water. Okay, and then we can see the water droplet becomes spherical. Okay, why? Okay, let we see first. Okay, how the surface tension occur. Okay, now this is how the surface tension. Okay, this is sorry, anything teacher Kong?
No. Okay, everything is okay. Can
All
continue.
right. So,
Or
I go to the surface tension. So this is the molecule of the water liquid. Okay, so we can see that the water molecule are held together by cohesion. Cohesion is the bonding between the same molecule, which is the water molecule, is hold together. Okay, and then the molecule at the surface, okay, the surface of water, we can see that it pulled downwards and sideways by other molecule. Okay, this is the first factor, the surface tension. And then the second one is we can see that the molecule within a liquid are pulled by intermolecular forces equally in all directions. So this is the molecule within the molecule, right? Which is the intermolecular forces is equally in all direction. Okay, so once when we put slowly, okay, the clip paper on the top of the water, we can see that the molecule is like some sort of a skin, build up like a skin. Okay, which is it have the intermolecular forces downwards and also sideways of molecule. But when we put the paper clip and we give some pressure, some higher the temperature, we put the some of the impurities in the water, so it will disturb. Okay, we break down the intermolecular forces. So for sure, the paper clip, which is the higher density, will go down of the water. All right, this is the surface tension. So we can say that the surface tension is allow object with higher density than water, such as a paper clip or insect, to float on the water surface, and then it is required to increase the surface area of the liquid. All right, so this is the third properties, and we see the fourth properties of liquid is because viscosity. Okay, what is viscosity actually? Okay, this is the resistant force of liquid against its flow. Okay, let me see the simple experiment here. Okay, I put the water into the bottle, which is I want to constant the size of the bottle. Okay, and then the shapes of the bottle, I want to make it constant. And then now, okay, we put the water we want to drop down the content of each bottle. Okay, we give 5 seconds. So now we can see that water, drop all the water here. Okay, and then soy sauce. Okay, and then tomato ketchup. Okay, we can see that didn't drop all yet. Okay, in the 5 second. Why? Okay, so this is the factors that determine the viscosity. Okay, we have the strength of intermolecular forces, size of shape of the molecule, and also temperature. If you can see that if higher viscosity, that means the strength of intermolecular forces is stronger. And also the size of the shape of molecule is greater, and also the temperature is lower. Let's say that we want to drop down the tomato ketchup. If you heating it, we give the higher temperature to the tomato ketchup, so it will less the viscosity. So from this simple experiment, we can say that tomato ketchup have a higher viscosity compared to soy sauce and compared to the water. Alright. Okay, now we go to the fifth properties of liquid, which is compressibility. Okay, now, okay, we can see that how to do the simple experiment here. Okay, we put the water into the shrink. Okay, and then we have a shrink here, and then we must cover the mouth of the shrink, and then we put some pressure there. Okay, we push it. So we want to see how it's compressed and nothing happened. Why? Okay, so this is because the particles are closely packed together. Okay, which is closely packed as compared to gas. The gas have a more space, is it? So it can be compressed easily. Okay. However, for liquid, yeah, it's not easily compressed due to the particle is closely packed. Okay. Now we see to the next properties. It is a diffusion. Okay. What is diffusion? We can see that liquid experience diffusions slower than gases. Okay. We see the simple experiment here. Okay, now what is diffusion actually? Okay, the diffusion is the process of movement of molecules from higher concentration region to the lower concentration. Alright, so once the molecule of liquid are arranged more closely than gas, that's everyone is already know that. So once the because of the arrangement of the particle in the liquid is more closely than gas, so the kinetic energy is lower as compared to the gas. So that the stronger intermolecular forces compared to gas. So that's why can see that the liquid diffuse slower than gas. So this again about the arrangement of the particle. Alright. Okay, so as a summary, okay, from the summary, we can say that for the properties of liquid does not have the definite shape and size, but it have a fixed volume. Okay, and then liquid do have the higher surface tension. Okay, and then for liquid to have the higher viscosity, it must have the stronger intermolecular forces. It must have a greater size, and also you have the lower temperature. So if we have the higher viscosity. Okay, for liquid, it's not easily compressed as compared to gas. Okay, meanwhile, for liquid, it will diffuse slower than gas. So this is all the properties of liquid. So now we see the vaporization and condensation based on kinetic energy and intermolecular forces. Okay, see how we heating the liquid. Okay, now we can see that this is what we call as a vaporization. Okay, which is the liquid particle liquid turn to gas. Okay, how did this occur? Because okay, when heat is absorbed, okay, kinetic energy of the particle become higher. It move faster. Okay, and then once the kinetic energy can overcome the intermolecular forces so that the liquid molecule will escape from liquid to become vapor. So the keyword here is it have enough kinetic energy to overcome the intermolecular forces. So make the liquid molecule will escape from liquid to become vapor. Like this. So it will become vapor. Okay, now this is the vapor molecule. Okay, let's say this is the vapor molecule. So what happened in the container, in the closed container? Okay, in the closed container, we can see that vapor molecules will be continuously moved in a random motion, and it will collide to the other molecule or to the wall of the container. The two types of collision between molecule or to the wall of the container. So and then okay, we collide. Okay, what happened during collision? Okay, during collision, it will lose the kinetic energy. Okay, it's collide, and finally the kinetic energy become decreased. So what happened is when collide at the surface of the liquid, okay, again, we talk about the vapor, right? So it's a vapor here at the surface of the liquid. When they collide at the surface of liquid, okay, kinetic energy become weaker than intermolecular forces, okay, due to the loss of Ke tadi kan. Okay, so that what happened? What happened is thus the vapor molecule binds to become liquid. Okay, so it will bind to become liquid. Alright, so this is what we call condensation process. So condensation process is gas to become a liquid. Alright. Okay, now okay, the next term so for this liquid topic is the vapor pressure and also boiling point. Okay, again, vapor molecule will continuously move in a random motion and we collide to the other molecule or to the wall container. And during this collision, we can see that they have a vapor pressure exerted. So at the surface of the liquid again, okay, during the collision, vapor pressure will be exerted. Okay, now okay, what is vapor pressure? Okay, this is the area of how vapor pressure is exerted. Okay, so vapor pressure is the pressure exerted by a vapor molecule above the surface of liquid. Here, this is this area how the vapor pressure will exerted. Okay, and then the unit of vapor pressure for sure is the pressure. So the unit is atm. We can use a kilopascal, millimeter, mercury, or torr. It's all the unit of the pressure. Okay, now when we talk about vapor pressure, we also explain about the boiling point. Okay, what is boiling point? Okay, now boiling point is the temperature at which the liquid boil and the vapor pressure of liquid equal to the external pressure. So at the surface area, this is the vapor pressure, and the outside here is the we call as the external pressure. Once the vapor pressure is equal to the external pressure here, so we can say that the temperature will reach the boiling point. So, and for sure, for the boiling point, the unit must be in degree Celsius, Fahrenheit, Kelvin, alright? So, and then we can say that vapor pressure is in inverted purposely and then inversely proportional to the boiling point. If the higher boiling point, it will lower the boiling point. Okay, now we see what is the factors affecting the vapor pressure. They have two. Okay, they have temperature and also intermolecular forces. Now, what is the first one is the temperature. What is the factor affected of the vapor pressure? Now we can see when we higher the temperature. Okay, now when T higher, the average of kinetic energy of liquid molecule will be increasing, especially at this area part. Okay, the hotter part ni will be more higher, faster. The molecule become faster. Okay, move faster, and then more liquid molecule have enough kinetic energy to overcome the intermolecular forces. So So once they move faster until it increase the kinetic energy, okay, so that it have enough kinetic energy to overcome the intermolecular forces. This is the red one is the intermolecular forces of molecule. So that when the kinetic energy greater, so we can say that more liquid will escape to become a vapor. When it can break the intermolecular forces so that it will escape to become a vapor. Okay. So we can say once the vapor pressure higher, vapor molecule higher, so the more collision will be occur and then vapor pressure also become higher. Okay, now the second factors is intermolecular forces. So now I give you two example of two different molecule. Okay, I give you molecule A as a ethyl ether. Okay, which is we know that ethanol consists of hydrogen bonding. Okay, and also weak van der Waals forces, while molecule B is only totally weak van der Waals forces. Okay, so for sure that we know that ethanol have the stronger intermolecular forces. So when the intermolecular forces is stronger, so fewer liquid molecule have enough Ke to overcome the intermolecular forces since it's the stronger one. Okay, stronger. So only fewer liquid will escape to become a vapor compared to the weaker intermolecular forces is a greater liquid molecule will escape to become a vapor. This is the difference. So what we can say, when less vapor molecule, okay, so less collision occur and vapor pressure will also lower. Since they have less collision, so also vapor pressure become lower. And then once again, when we talk about vapor pressure, we relate to the boiling point. So for these factors of molecule A and molecule B, since the molecule A is a greater, the stronger intermolecular forces, so it needs a higher boiling point to break the bond. So that's why the VP lower also cause the BP higher. Okay, so for molecule A, it have a higher boiling point and lower vapor pressure. Okay, now we talk about boiling point. Okay, boiling point, okay, definition I already mentioned. So, but it still have the factors that affecting the boiling point. Okay, now it have purity, it have atmospheric pressure, and also it have intermolecular forces. Okay, the first factor is purity. Okay, yang ni you dah belajar since sekolah rendah lagi. So how we compare the boiling point of water and salt water. So I give the first bottle, the first container, I put a salt there. Okay, now if we heat it, okay, and then the presence of impurities will increase the BP supposedly. So now the first container I put the salt. Okay, now once we heat it, okay, when we measure it with the thermometer, we can see that boiling point of salt water become 120 degree or something like that, or and then boiling point of water become 100 degrees Celsius. This is the boiling point of common water. So this is when we put some impurity, so it will increase the boiling point. And then the second factors of boiling point is atmospheric pressure. Okay, at higher altitude, we can see that the boiling point of water decreases, which led to the longer cooking time. So this is a bucket. We have some bucket here. So this is when we cook the water at the sea level. Sea level is our house is a sea level, which is all 180 M pressure. Okay, when we boil the water, it will reach 100 degrees Celsius. But at a higher altitude, the boiling point of water become decreasing, which is when we boil it, it only reach 90 degrees Celsius. So what happened? We'll need to longer the cooking times. Mungkin 5 minutes it reach the 100 degree. But for a higher altitude, we need to boil it in 15 minutes. So it will boil the water. So this is the factors of boiling point. Okay, atmospheric pressure. And then we have a pressure cooker here. Okay, for pressure cooker, once we higher the pressure, we can see that the pressure of the pressure cooker is increasing. Maybe it will reach to the 1.5 bar per minute. or 2 atm pressure here. So what happened is boiling point will reach 120 degrees Celsius, which is increase the boiling point with the same time, but it increase the boiling point. So what happened is food will be cooked faster. All right, this is how we implement the boiling point in a higher altitude or in the in the pressure cooker. Okay, and then this is dalam exam pernah keluar dia keluar is this kind of the graph which is pressure against temperature, which is boiling point here at the 1 atm. Okay, we can see that the boiling point of ether is 35. Okay, at 1 atm the boiling point of ethanol is 78 and water is 100 degree. But once we increase the external pressure to 2 atm, so we can see that water boiling point become increasing. Okay, maybe it become 120. Okay, right. Okay, so now we go to the next factors of boiling point if intermolecular forces are the same like the previous slide, okay, which is when the stronger intermolecular forces, okay, it have fewer molecule to overcome the intermolecular forces, again fewer liquid will escape to become a vapor, okay, and finally when less vapor molecule, less collision, MVP also lower, and for sure boiling point become higher. That's why for ethanol, it have a greater boiling point as compared to diethyl ether due to the difference of intermolecular forces, which is ethanol, it must be stronger one lah. Okay, now, okay, this is the same graph. So what we see here is when the intermolecular forces, okay, water for sure have a stronger intermolecular forces, which is all hydrogen bonding. Okay, so at 1 atm, the boiling point become 100. Okay, meanwhile, because ethanol have a weaker intermolecular forces because it's content of weak van der Waals forces and also it contain of hydrogen bonding. So its boiling point become lower, which is 78. Okay, 78. So ether, it have all weak van der Waals forces, so its boiling point is only 35. When we boil it in 35, it's already vaporized. Okay, so this we can relate it to the volatility. For STPM syllabus, you must know about the volatility. So which liquid is the most volatile? Means that kita baru je heat dia. Okay, and then dalam masa 5 second, 10 second, siapa yang akan vaporize first? Dia akan volatile first. Okay, so this is the ether. The answer is ether, since it have the lower boiling point. So this is the most volatile liquid. Okay, followed by ethanol, followed by water. Alright. Okay, so for the first part, we explain about liquid. So this is the question about liquid. So we wait for student to answer. Alright, shapes of drops of liquid are spherical because of what? Okay, we have viscosity here. We have conductivity, we have absorption, and also surface tension. So what is the answer? Okay, Teacher Kong, we give for 10 seconds for student to answer.
Okay, sure.
Okay, shapes of drops of liquid are spherical. Spherical is like a water droplet. Why water droplet is become a sphere? So what is the factor? Okay, any student?
Okay, no, not yet. Maybe we can, Cikgu Mawar?
Sorry?
Cikgu Mawar? Maybe we can stop for a while for advertisement.
Okay, so this shape of drops of liquid are spherical because, okay, now, okay, the surface tension, why? Why surface tension? Okay, so now this is how the surface tension, okay, water droplet, why is a sphere, can? Because of the structure, okay, I earlier I already explained to you because of the attraction force, because of the intermolecular forces is a sideways and pulled downwards. Okay, so this one is also pulled downward.
Oh,
This one is also pulled downward. This one is also sideways and pulled downward. So it become a sphere. All right. So make it they become a sphere. So this is still about the surface tension. Okay. The second question. Two liquids P and Q of the same volume are allowed to evaporate. So it is found that P evaporates first before Q does. So which statement explain this observation? Okay. So we have P and
hi,
Q.
Cikgu Mawar.
Yes.
Shall we stop for a while for advertisement?
Yes, Teacher Kong. Alright. Boleh.
Shall we stop for a while for
Tuisyen
advertisement?
online percuma.
Okay, thank you.
Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okay, welcome back. Okay, again we at the second question here. Okay, two liquid P and Q have the same volume allowed to evaporate. So what can we observe? P evaporate first before Q does. So what is the correct answer? Vapor pressure of P is lower than Q, or intermolecular forces of P is weaker than Q, or density of Q is higher than P, or Q is more viscous than P. So what? Any answer, Cikgu Kong? Okay, so I just proceed. So the answer is B, which is intermolecular forces of P is weaker than Q. So that's why it evaporate first. So means that P is more volatile compared to Q. All right. So once we talk about evaporate, we must relate to the intermolecular forces, and then we talk about the volatility, vapor pressure, boiling point is all related to the evaporate. Okay, it's not related at all about density or viscosity is out of the answer lah. Okay, now the third question, the vapor pressure is directly proportional to the temperature because of what? Vp higher, so temperature also higher. Why? Okay, why? Okay. Okay, any answer from student? I think there's not many students there.
Not yet.
Teacher Kong keluar
Still
Okay.
waiting.
Still waiting. Okay. Never mind. Okay, so because I want to proceed to the solid part. Okay, now the answer is okay for sure. When we talk about the vapor pressure and temperature, once we hit the particle, for sure the particle will move faster first. Okay, once it move faster, so what happen when the particle move faster? Yes, for kinetic energy will be increasing. So the answer is donkey lah. Alright, the answer is D. Okay, now we go to solid part. Okay, for the solid part. Okay, so this is the properties of solid. Okay, so this is the ice, which is the ice is in a solid structure. Okay, now we know that the particle is closely packed like this. Okay, so a solid has a fixed volume and shapes. Okay, and then the particles in a solid are closely packed and strongly held in a fixed position. Okay, and by strong attractive forces. So therefore, solid cannot flow freely like gas or liquid. Okay, that's why ice dia macam ni because of the closely packed of the particle. And also solids are extremely difficult to be compressed. Right? Okay, now this is the physical process of gas, of a liquid, of a solid. So I didn't mean to explain in detail because you already learn about this since you are in sekolah rendah lagi, form 1, form 2 is you akan sentiasa jumpa this kind of syllabus, this kind of content. Okay, but how to explain why this is occur, that the thing is you must know. Okay, so the keyword here is kinetic energy overcome the attractive force. Okay, we can see here is the particle of solid. This is the particle of liquid. This is the particle of gas. We can see that the particle moving apart. Alright. So, which one have the greater attractive force? Intermolecular forces. Okay, for sure is the solid. Solid have lower kinetic energy, but it have a stronger attractive force. That's why it's a closely packed. Okay, so once kinetic energy can overcome the attractive force. Let's say that when we hit the solid, we hit the solid particle, we hit the solid thing, and then what happened to the particle? It will move faster, and finally it have the stronger kinetic energy. Okay, finally, once the kinetic energy can overcome the attractive force, and then the particle keeps moving apart, what happens is the solid state will convert into gas. Okay, this is what we call as sublimation. Okay, the same thing is when we hitting the solid and then the particle keep moving apart, what happens is when the kinetic energy overcome the attractive force, it will turn into liquid melting or fusion. Metric called as a fusion, is it? Okay, so melting or the fusion is the same process lah. Okay, so it will turn into liquid. Same goes to liquid to gas. Liquid also have a higher kinetic energy compared to gas. So once it's a lower kinetic energy. So gas have a greater kinetic energy. But intermolecular forces of liquid is greater than gas. But once when we hitting the liquid, what happen? It move faster. The particle move faster, and the kinetic energy become increasing. So until it have enough energy to overcome its intermolecular forces, its attractive force, so that it will vaporize into gas. So this is all the physical process of the three states of matter. So the keyword here is you must explain it until kinetic energy can overcome the attractive force, so that from solid we turn to gas, the solid we turn to liquid, and also liquid we turn to gas. Okay, when the particle move faster. Alright, so this is the physical process. Okay, now, okay, we have the two broad categories of solid based on the liners of their particle. So we have two types. We have crystalline solid and also we have amorphous solid. Okay, this is how the structure of crystalline solid, which is we can see here it's well-defined shape. And also it is have a regular 3D arrangement. Okay, so example of crystalline solid here is we have salt, we have diamond, and also we have ice. Okay, this is a kind of crystalline solid. It have a well-defined shape. Okay, meanwhile, for amorphous solid, if you see that the structure have a lack well-defined faces and shape. Okay, dia berterabur tahu susunan dia. And then the particles are randomly arranged with no orderly. Alright, so what kind of solid that under amorphous solid? Okay, we have a plastic, we have a bottle, and we have a rubber. Rubber, bottle, plastic is a kind of amorphous solid. Alright, okay, now I go to next one. Okay. We go to the lattice structure of crystalline solid. Okay, we go to the lattice structure of crystalline solid. Okay, we have 4 types. Okay, the first one, we have ionic crystalline solid, ionic solid. Okay, the example of ionic solid for sure is sodium chloride. Sodium chloride, which is content of anion and cation. So this is kind of ionic solid. Okay, ionic lattice structure. So this is the same thing lah. Okay, the second one, we have metallic structure. Okay, metallic structure is have a metallic bond among them. So this is an atom metal, which is a group 1, group 2, and also a part of group 3 aluminium. So for metallic structure, it have the C of delocalized electron. So the example here is magnesium. We have sodium, we have aluminium. So this is the metallic structure of crystalline solid. And then the third part is simple molecular. Okay, simple molecular is a molecule. Bila disebut simple molecular, for sure it is molecule. But is a simple one, okay, which is it have a covalent bond and it have a weak van der Waals forces or hydrogen bonding for the its intermolecular forces. Okay, it can be hydrogen bonding or weak van der Waals forces. So the example of simple molecular is iodine. We have carbon dioxide, we have oxygen gas. So this is all the simple molecular simple molecular. Okay, now we have a giant molecular. Okay, giant molecular. Alright, for giant molecular, okay, we have a covalent bond here, and also the example is we have a diamond. Okay, diamond. We have a graphite. So this is the graphite. We have a silicon dioxide. So this is SiO2, silicon dioxide. Okay, where we see here is the giant molecular for graphite. It contain of sp2 hybridization. So this is sp2 because so it will shape trigonal planar shape. So it have layers, the layers of planar shape. Okay, between the layer, it contains of weak van der Waals forces. So once again, the because of the graphite have a sp2, so it have one delocalized electron. So that's why for graphite, it can conduct electricity because of it content of delocalized electron. Okay, meanwhile, for diamond and silicon dioxide, we can see that it is a sp3 hybridization and it is tetrahedrally shape. Okay, tetrahedral 4 dekat sini. Bonded to 4. Okay, so that's why it's become sp3 hybridization. So this is a simple molecular. If we prefer to the solid, so this is iodine is a simple molecular solid because this two is a gas. Okay, so when we talk about solid, for simple molecular, we refer to the iodine. Okay, now this is all the lattice structure of crystalline solid. Okay, now, okay, this is we go to the allotropes of carbon. Okay, allotropes of carbon. What is allotrope? So for allotropes of carbon, this is the STPM syllabus. STPM syllabus have an extra part compared to metric, which is allotrope. What is the meaning of allotropes? Okay, allotrope is a different forms of the same element in the same physical state. It's all solid, but it have different form. Okay, they occur due to the different bonding arrangement, and it have different physical and chemical properties that we see about diamond first. So this is how the diamond form. Okay, this is the diamond structure, which is it is a tetrahedrally shapes. Okay, this is all made up by carbon, made up by carbon. So this is carbon bonded covalently to the another carbon, okay, until it form the tetrahedrally shape like this. So this is the diamond properties. Is very hard, insulator, insoluble in water, very high melting point, and it is sparkling diamond kan. So you must sure it's sparkling. And now we see about the graphite. This is the graphite. Okay, this is a layer of graphite. Okay, and then you have multiple layers. Okay, and then in between the multiple layers is bonded by the weak van der Waals forces. So this one is a weak van der Waals forces. So graphite again, it is a soft and slippery. It is electrical conductor because of it have the localized electron and it also insoluble in water and very high melting point. Okay, so now the third one. So ini yang paling jarang kita tengok is a fullerene. Fullerene is paling jarang. Okay, let we see how the fullerene structure. Okay, this is fullerene of C60. It's made up by 60 carbon. 60 atom of carbon here. So if what we call fullerene is also called buckyball. We said it as a buckyball, macam bola sepak lah. It's like a bola sepak. It's a sphere shape. Okay, if you realize that for fullerene, it have kita kata that it have a hexagon shape. Okay, hexagon shape of carbon and also it have a pentagon shape. Bila hexagon combine with pentagon, baru kita akan dapat a sphere shape. Kalau kita nak buat bola sepak, that kita guna is all hexagon, we will never get the sphere shape. Maybe kita akan dapat bujur lah. Okay, oval shape. So, but to get the sphere shape, we must build up by the hexagon shape and with a pentagon shape. So, we will get the sphere shapes of fullerene. Okay, the properties of fullerene is soft and slippery, electrical conductivity since it's also sp2. It's also sp2. Okay. Okay, and then it's insoluble. It's electrical conductor, but it's not stronger like graphite because its localized electron is susah. Dia susah nak delocalize because of the greater structures of fullerene. And then low melting point, soluble in organic solvent. So this is 3 types of electrodes of carbon. Okay, now I already covered the solid part. I already covered the liquid part. So now we go to the questions. Okay, we go to the questions of solid. Okay, each carbon, fourth question, each carbon atoms forms 4 covalent bond with the other carbon atom, arranging them tetrahedral in, okay, what kind of solid here? It have carbon atom form in a 4 covalent bond. It bonded with the other 4 carbon atom arranged in tetrahedral. So which one? Okay, student. Okay, I wait for you to answer. Okay, Teacher Kong.
Cikgu Mawar, Jin Chai answer B.
Okay, Zinchai. Good. Very good, Zinchai. Okay, Donkey. Okay, we see. Is it C? Yeah, C ya. Tadi Zinchai answer C ya.
Boy.
Oh boy, okay, very good. So the answer is diamond lah for sure because it's
Chaying also answer
tetrahedrali.
boy.
Okay, very good. Okay, very good. Okay, Chia Ying and Zinchai, very good. Okay, so we go to the next question here. Okay, the change from liquid into the gaseous state is known as liquid to gases. Liquid to gases. Okay, from closely packed to the less closely packed of particle. So what we call the process? Is it vaporization? Is it condensation, freezing, or sublimation? Okay, wait for student to answer. Okay, for this chapter is more to concept lah. Solid, liquid is more to concept. It's not like a gas chapter. Gas chapter is more to calculating, is it? Okay, so this is the easy question. Liquid to gas. Okay, ada answer tak, Teacher Kong?
Yes, from Jin Chai 5A.
Okay, so Zincha A, right. So what is the answer? Yes, correct lah. Vaporization for sure lah. Liquid vaporize into gas. Alright, next. The carbon atoms are arranged in planar layers in tin, graphite, diamond or mercury? Okay, carbon atom are arranged in planar layers. Okay, you have layers. Tadi ingat tak structure apa yang ada layers? Is it tin, graphite, diamond ada layers tak? Or mercury? Okay, we wait for student to answer. Okay, I think Chia Ying as in Chia is a very good student lah. Selalu fokus. Selalu join
Yeah,
our
very good.
class.
Yes, they are hardworking.
Very good student. Okay, the carbon atom are arranged in a planar layers. So planar layers tadi dah tunjuk video, dah ada dah video of the planar layers. So the answer is for sure graphite lah. Graphite is arranged in a layers, and between the layers is bonded by weak van der Waals forces. That's why for graphite is easier to slide kan. Okay, now which is the correct crystal structure for the substance name? Okay, tadi we have 4 types of structure. We have ionic, we have a metallic, we have a simple molecular, and also we have a giant covalent. But you must know the substance that belong to this kind of structure. So which one is the correct one? Okay, for simple molecular, is it iodine? Ionic, is it diamond? Giant covalent, is it sodium chloride? And also metallic, is it graphite? So try to answer. So ini paling famous keluar lah dalam kalau SGPM tu memang every year mesti ada keluar this kind of question. So that you must know the structure and the example of the substance. Right?
Jessie Chai answer 7A. Is it correct?
Okay, Chai answer A. Okay. Let me see the answer. Yeah, so this is the answer. Ini tadi notes. Okay, we can see here. This is the notes here. Okay, so for sure betul lah. Iodine is a simple molecular solid lah. Kalau kita talk about solid, yes, iodine. Alright. Okay, and then we know that diamond. Diamond is belong to the giant molecular. Ionic for sure garam lah. Any salt is ionic. Any salt. Copper sulfate, we have sodium chloride, we have magnesium chloride. It's all ionic. Okay, and then giant covalent, you have 3 ni lah, SiO2, we have diamond, we have graphite, and also metallic is all group 1, group 2, and group 3 is the part je lah, yang mana yang metal is a metallic structure. Okay, so we have magnesium, sodium, aluminium, and ni dah answer 8. Okay, and then any question? Okay, dah tak ada dah. So we finish earlier for today. Okay, this is a simple what we call simple chapter, solid and liquid. And I hope that all of you can cover this chapter well, can answer all the question well. Since the metric is an objective question kan, so nanti you buat banyak-banyak question. Okay, Teacher Kong, I think we finish earlier today.
Okay, thank you, Cikgu Mawar. With God's grace, we are done with today's section. We have learned a lot from Teacher Mawar about liquid and solid. Congratulations to those who are able to follow our section from the beginning to the end. And thank you very much, Teacher Mawar, for such an interesting lesson. Before I provide the certificate link, please check the check box for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Teacher Mawar for giving you a free lesson today. Don't forget to click the bell button too so you won't miss out any new video and live classes from Teacher Mawar. If you liked today's lesson, please click like and share it to your social media friends. Let's share the knowledge you receive today with them. Sharing is caring, right? When you have finished, type done in the chat section. Then I will give the cert link. Okay, now I would like to give the last three passcodes. Okay, please stay alert. The last three passcodes are 7, 2, 8. 7, 2, 8. 7, 2, 8. Okay, once again, I would like to thank you, Teacher Mawar, for the interesting lesson. Thank you also, Teacher Bibilau and Sir Shannon, for being with us today. I think that's all for now. See you all in another section. Goodbye, everyone. See you all again in another section. Goodbye, everyone.
Bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.